G'day, humans. Welcome to the safe space for dangerous ideas. And it's the most dangerous idea out there, the question of are we alone in the cosmos? You might have seen some reports recently that suggest, in fact, we have just discovered we're not.
In a world more than 120 light years away, scientists say they've found the strongest signs yet of extraterrestrial life.
Astronomers detect a signature of life on a distant planet.
Signs of life on an exoplanet? What's up with that?
Being something of a nerd of the cosmos and alien life and sci-fi myself, I wanted to get to the bottom of this with someone who I trust, who is an expert in this field, and ponder not only on what exactly this latest discovery really means, but on all kinds of things to do with whether we're alone in the cosmos, what the purpose of the cosmos might be, why it seems fine-tuned for life, whether or not life originated on planet Earth or elsewhere in the galaxy, how we look for alien life, what we might be missing, why we haven't found any. I wanted to address the Fermi paradox, which is, basically this conundrum about why, if the conditions required for life to arise are as permissive as the evidence on planet Earth seems to suggest they are, then why isn't extraterrestrial life abundant, and why isn't it sufficiently common to have been detected so far? The person who I turn to for all such questions is Sara Webb. She is an astrophysicist at Swinburne University of Technology in Melbourne. She is really one of the rising stars of astrophysics globally. She did her PhD in machine learning for processing astronomical data, which is coming in particularly handy at this moment of artificial intelligence. She also runs the microgravity experimentation unit at the Space Technology Industry Institute and gets to send crazy things up into space. She has just gotten back from an all-expenses-paid trip to the United States organized by the State Department of the US, at least until Elon takes his chainsaw to it, where she traveled to the Kennedy Space Center in Florida and met with other high-flying physicists and astrobiologists and all kinds of brainy people. I loved this conversation, and if you're interested in the fate of humankind as it relates to other civilizations in the cosmos, you will too. The one, the only, Sara Webb. What was Kennedy's face like?
Oh, magical. I cried multiple times. That was great. That was fantastic. I think we forget how many human worked on getting us to the moon. Like 400,000 individuals made that happen. And I think, at least for me as a scientist, the bit that I think is so beautiful is all the trickle-down technology and the things that me and you use every day that had to come from a program like that. So I love that.
I was trying to show, I showed my kids Apollo 13 and tried to impart to them what it would have been like before humans had ever walked on the moon. And they're only 7, so they're frankly more interested in like the gadgets and widgets and like what it would have been like in the cockpit when they're on the ground than they are. We had to turn off halfway through because they were like, is that the worst thing that happens after all the power goes out and they're stranded? They're like, does anyone die? Are there any more explosions? I was like, just watch the movie. They're like, no.
Like Tom Hanks needs them right now.
It's not impressive enough. I'm sorry. They're a tough crowd, man. They're harsh.
A bit.
So when we look for extraterrestrial life on planets that are not in our solar system, how do we look for it?
Oh, all sorts of ways. This is probably one of the most fascinating things. So you can look for it in main 2 ways. So one is called a biosignature. So you're looking for chemical compositions that we know that we make here on Earth as living organisms. We're looking for that. And then the other way is called a technosignature. So we're looking for signatures that only intelligent, if we deem ourselves intelligent, only intelligent beings are able to make. And that normally comes in the form of radio signatures.
Right. And those biosignatures are what? Are they basically breathing out and pooing and stuff, or what?
All sorts, yeah. So it could be things like, the big one is dimethyl disulfide or sulfide itself. So there's 2 forms of it. Both of them are made with phytoplankton. So it's oceans, it's living, breathing ocean bacteria that really, it's the formation of where life kind of came from on this Earth. And we know that if you find that, you're likely teeming with at least phytoplankton and then likely other basic organisms. But you can look for other things as well. So one interesting one is actually looking for carbon dioxide changes, because we know that in our atmosphere, our carbon dioxide levels are changing, and it's because of us. And so if an alien was, say, watching us, they could, over time, assume that maybe we are alive, not only based on our other biosignatures, but on the fact that we're producing this other chemical that isn't necessarily from us living and breathing directly, but from what we're using on the Earth.
Right, and even if we weren't technologically sophisticated and pumping out carbon because of our machines, we would be, just because living things do.
It's still living signatures.
Yeah, right.
Absolutely. Yeah, leaving them here, there, and everywhere.
And so what was this discovery that everybody is in a tizzy about at the moment, where supposedly we've discovered alien life? Tell me we have.
Oh, I wish I could. I really wish that I could jump on here and be like, we have found aliens. But the reality is we haven't. Not yet, at least. So the tizzy, and I think that is a fantastic word to use, is over something called DMS. So that was that dimethyl sulfide or dimethyl disulfide that I mentioned. These two compounds that can only be made by life. Now, what happened was that there's this amazing exoplanet called K2-18b. It is an exoplanet that orbits a red dwarf a little bit away from our own solar system, and it's been of interest for several years now because we think it's really interesting. It's bigger than the Earth, but it might sit in the habitable zone, so it might have liquid water. We can't quite tell what it is, and the authors of this specific paper are very of the opinion that it is a Haitian world, so it's a water world, and that would make sense if they think they've found this signature that really only occurs from photoplankton.
You mentioned the habitable zone. What's the habitable zone?
Yeah. The habitable zone, or the Goldilocks zone, is this area around a star where liquid water can survive on the surface. So we happen to live in the habitable zone of our sun. But if we were any further out, say if we were at Jupiter, our Earth wouldn't have liquid water on its surface. And same as if we were too close. It would just boil away.
You say we just happen to live on it, but of course we don't happen to live on it. We could only live on it because it is here.
We could only live on it. We happily evolved to this beautiful planet.
That's right. There is no universe in which we're living on a world on which we can't live and are going, isn't it amazing that we live on a world where life is impossible? By definition, it has to be. We have to be living in the habitable zone because we're inhabiting it. So we go around looking for these planets that are in the Goldilocks zone, where it's not too cold that the water would be ice, and it's not so hot that the water would be steam. And then we try to look for whether or not if there were liquid water on that planet, whether it might contain life by analyzing the gases or the changes in gases on the surface of that planet. How do we see gases? How do we know what the atmosphere is on something that is so far away that it's just a tiny pinprick of light in the night sky?
So what we're able to do is use something called spectra, where we take light and we split it into its very discrete wavelengths, and we look for absorption or emission lines. So this is either where you've got, say you have a certain gas and it might absorb a certain energy level, so you don't see that in the light, or it might emit a certain energy level. There's a beautiful example of what our sun looks like when you split it through the spectrum. It's a beautiful rainbow with all of the black lines where there's absorption features. So that's essentially what we're doing. The problem is that it's extremely, extremely difficult to do it from here on Earth. We have our own atmosphere that gets in the way, and the resolution is really hard. So we can only really do it very well from space. And that's where the James Webb Space Telescope comes in, and it's able to not only take spectra, but take it from space, where we've got this amazing resolution, and look for these absorption and emission lines.
So the absorption and emission lines, just to clarify, I'm still a bit confused about how a spectrometer, if that's what it's called, even works. Because we're not talking about a star here that's emitting its own light. We're talking about a planet that doesn't emit any light, but we're glimpsing light reflected from its nearest star, are we? And the wavelengths of that light are different depending on what the gas composition of the atmosphere is, or what?
Yeah, we can do it in two different ways. So one way that we can do it, and the way that particular studies at the moment are doing it, is you have a sun, so pretend I'm the star and this is a planet. You take a spectrum.
Most people listen to this and they don't watch the YouTube, but I'm just going to say that you're holding up a fist as if you were a star. Let's describe it. Yeah. Okay. So let's paint an auditory picture for us, Sarah.
I will. Okay. So imagine you have a star and it is shining incredibly brightly, and you take the spectra of that star first, and you take that and you split its light up and you get its fingerprint, essentially. You then wait until you have the planet cross in front of the star. So all of a sudden, that planet is now blocking out a little bit of that starlight. But some of that light is also traveling through that planet's atmosphere. So you're getting two things that are happening here. You're getting an addition of light traveling through the planet's atmosphere that will contribute to now this overall spectrum. And then you wait for the planet to move away. You do essentially a subtraction of what you know the star looks like and this new data where the planet was in front of it, and you look for features that weren't there before. It's incredibly complex and incredibly precise. And this is why there's a little bit of controversy around this result, because it's a maybe. It's a maybe, and it's not a nail on the coffin quite yet.
And often is it the case that we can't even see these planets at all, and we're only inferring because they're so far away and they're so tiny and they don't emit their own light. So the way we actually look for the planets is by looking for stars that just dim slightly and then get brighter and less bright, and we assume that they're getting less bright because a planet's passing in front of them, and then we go, all right, well, let's just infer the existence of this hypothetical planet and then see if, as it goes in front of the star and dims the star a bit, the star's light changes in its complexion, implying that it's traveling, that the photons are traveling through the atmosphere of another body.
Yeah, that's exactly right. So what is incredible about that is that it's all inference. They're making it based on scientific hypotheses that because the light has dimmed, we think there's a planet there. And we watch it dim over and over, and we get these parameters that we think confirm the existence of a planet. But it's not like we're able to see that planet in great detail. So with this K2-18b, the one that's causing all the controversy, we have no idea what it looks like. We can't look at it and say, yes, you are an ocean world, or yes, you're a gas giant, or maybe you're a lava world. We don't actually know. And that's why we have to get all of those little pieces. It's almost like doing investigative
forensics or something. Yeah.
Forensics,
it's like
exactly,
LA
of the system to
Law and
piece
Order.
Together.
Yeah.
Yeah, Law and Order. Solar System Edition.
And how do we know, when we say that the planet's in the Goldilocks zone, how would you know just because the star that is its local sun is dimming and getting like lighter and darker where the planet is? It could be closer to us and big, or it could be further away and smaller. How do you know how far from the star it is to infer that it's in the Goldilocks zone at all?
So we can use Kepler's laws. We can go back to lovely Kepler principles to determine the mass of the planet that we think it is, and then also its orbital mechanics around that star. So we have to see it pass in front of it multiple times to be able to get a really good estimate. And then based on the star itself that it's orbiting, we know how much light those stars emit, essentially. And then from there, we can do the maths for how warm would it be. So our sun is very different to the majority of stars in our solar system. Our sun is actually very bright. And so if we were to pick up the Earth and put us near an M dwarf, which are about 80% of the stars in our galaxy, we would freeze. We would be too far away from that star, even though for our one, we happen to be perfect. So it changes. Depending on your star, it will change quite dramatically where life, in theory, as we know it, is able to form.
Wait, I thought our sun was a small star.
Smallish.
But above average?
What we call it.
I'm a man. I'm just obsessed with having size that's larger than everybody else, okay? I want our star to be in the top half.
She's what we call a G dwarf, which is not representative. We call her a yellow G dwarf star. So the sun makes up about 7% of the type of stars that we see in our galaxy. And in theory, it's quite tiny compared to some of the stars that we get out there. We get ones that are absolutely enormous, but they're rare in comparison to M dwarfs, which, are 80% of the stellar population.
So is our sun bigger or smaller than the star that this new planet is orbiting?
Bigger.
Yes. Excellent. Take that.
Yeah, we win.
Take that. We win. So if there are aliens, then we can engage in some kind of a big swinging dick competition with these aliens and we will win.
Oh, absolutely.
Fabulous.
Yeah, we can put it on T-shirts. Our star's bigger than yours.
And exactly. So just to clarify, in terms of the distance of the planet that we're in, whose existence we're inferring on the basis of the light from the star, we know where does the Kepler thing come in? Is that because we can see the star wobbling or something as the planet goes around and infer what the gravitational tug of the planet is or something? Like, I'm still not clear about how we know how far away from the star the planet is, because if it was bigger, it could be closer, and if it was smaller, it could be, further away from us, and it would still occlude the light source the same way.
Yes. So there's two key factors. The tugging is one other method. That's called radial velocity, where we can use gravitational influence to determine it. But just using the blocking out of light, what we do is it's the time period that light is dipping for. So say you have a dip that only lasts an hour. Then from there, you can calculate, well, how big and how far away do I think it has to be for that to be true?
I see.
So it's lots of data collection and then modeling based on that.
Amazing. Scientists are clever, aren't they? So if we need to... So what are the potential other explanations for this discovery then, if it's not life, if you want to pour cold water on it?
It might not be real. It could just be a signal that is not what we think it is. So what they've done essentially is taken this spectra. They have found a slight absorption, so that little dip in the spectra, and then they've modeled it to what they think DMS should look like, and then done statistics on that. It all sounds very, very sciencey. The TLDR is essentially, it's like a kind of maybe match bit, but it's not statistically at the confidence level that if you're going to stand on a rooftop and say, I have found aliens, you wouldn't do it with this confidence interval. You'd be a bit embarrassed. So I think this is something that is, it's fascinating, and we will hopefully get more and more data from it. But I think as a science communicator and a scientist myself, there's danger in proclaiming things too early, I think. And what I was quite surprised with, if I want to be really honest with this, with the way that it was handled, was the paper itself is a very measured, very good scientific paper saying that this is what we think we have found, these are all the limitations, and this is why it could not be true, possibly, which is a good science paper. You always leave things open. But then the dichotomy of that was that the first author had this brilliant quote that essentially said that this is a water world teeming with life. And of course, if you're media, that's a fantastic thing. How incredible is that? And I think that's where it's a little disappointing.
Yeah, I mean, science
because
journalism...
I too was excited. I wanted the aliens.
I mean, this is one of the fields where you can see how bad, how illiterate most journalists are scientifically, and how willing that they are to throw overboard the normal caution that they would apply to other issues like politics when it comes to issues of science. And there's so much clickbait and so much hysteria around it that I'm more skeptical of mainstream science journalism than many other fields of journalism. It is a bit disheartening. Unless we talk to the likes of you, Sarah.
It can go either way. Thank you very much.
Which is why I do so. And so, would there be? Do we have the ability to detect life on a planet of that size and that distance with a level of certainty that would have you saying that you're confident, or is this just a limitation of our abilities?
In theory, yes, we do. So, what would be confident for us is, this is going to sound extremely boring, but it's something called a 5 sigma detection. It is when statistically your models are 99.9999% accurate. And that is a confidence interval that I think most scientists would say we're very confident that that signature is real in the data. And then from there you say, well, what causes that signature? It can only be life. Therefore, we're inferring we've found life.
I mean, that sounds like a ridiculously high bar, though. 99.999%. Like, that's outrageous. We don't expect for that level of certainty in almost anything except for maybe aviation safety or something. Like, I mean, what percentage? What percentage should we assign to the current one? Is it as low as, like, when you say it's not certain, does that mean it's 98% or does it mean it's 70%?
It's still it's just above 99%, but it's not. I know people hear that and go, oh my
So you're
goodness.
saying
well,
there's a
that's pretty high.
99% chance we've discovered aliens?
99% chance that the model matches the model they fitted. But the cheeky thing with Bayesian statistics is that if you actually break it all down, there's a 27% chance that that model is incorrect.
I see.
Or doesn't quite fit as well as we think. So this is another thing. It's all of these it's a numbers game of trying to describe very complex data. And I agree, 99.99999 is an insane accuracy. But when you're thinking about things such as trying to say that there's life out there in the universe, it absolutely is the certainty that our scientists would want to see.
I understand that. I would be happy to take 99% instead of 99.999%. But once you throw in the red herring of there's a 27% chance that the model is wrong, that upends the apple cart completely. It reminds me a little bit, Sarah, do you remember I don't remember what this example was, but if you ask a person in the street, this came up in the case of DNA testing in criminal trials, where, if you ask a person in the street, the odds of this DNA test not being accurate in implicating the convict or the accused is 1 in a million. But the odds that the police mishandled it and contaminated it and it's not the right DNA is 1 in 100. So what do you think the total risk of it being wrong is? A layperson will say, well, it's probably somewhere between 1 in 100 and 1 in a million. So it's probably 1 in a half million or something like that. But of course, that's wrong. It's 1 in 100. If there's a 1 in 100 chance that the DNA was contaminated, then there's a 1 in 100 chance that it's wrong. So forget about the 1 in a million altogether, because the DNA, whether or not DNA is super accurate, is irrelevant if you're dealing with some knuckleheaded gumshoe who accidentally, had saliva on his hands when he was handling the test. So this is a little bit like that. We shouldn't think about 99% then. We should think about 73% if we're talking about whether the model is 27% likely not to be true. Right.
And not to not get excited. I live for the day that I get to proclaim very excitedly that we're not alone in the universe, because I'm of the team that there is absolutely alien life out there. Statistically, it would be silly to think that we're the only ones. And in my own opinion, it would be sad to think that this is it. This is it in the entire grand scheme of the universe. Earth is all we have. So I hope that in a couple years' time, when we get more data, more fitting, and maybe we get that 5 sigma tick mark, that we get to say that we've discovered alien life and that we're not alone. I don't know what that would do to the world, chaos-wise, but I personally, I live to see that day.
Honestly, I mean, 5 or 10, 15 years ago, I would have said that it would upend everything. And now I feel like we're so insular and so absorbed by our petty squabbles that most people would be like, oh, okay, that's interesting. It's a long way away. Yeah, what's Trump doing? And so just explain to me, if it's possible to explain to a person who's scientifically illiterate, where the 27% uncertainty in the model derives from. Like what could be wrong?
So it just could be the model fitting itself. So the statistical likelihood that the model is actually fitting it. You can almost imagine you're drawing 2 lines and trying to make them fit. So there's something called Bayesian statistics, and it's what we use a lot in lots of science, but in astronomy in particular, to actually estimate how correct we are about a result. So this still is a fantastic result, and I think it's an excellent paper and a really exciting possibility. But I think there's a couple of those little red flags that I would be worried about. And one of the big ones I did want to mention, especially for just the public's own scientific literacy, is so this is a discovery using the James Webb Space Telescope, which is a NASA asset, but this was not a NASA press release. And that might not mean much to a layperson, but it's something you've got to remember is where are the press releases coming from and who is backing extraordinary claims. And I think that's a big one, because if this had been that 99.9999% detection and everybody in the scientific community had the same consensus that this was it, NASA would be backing that. But that's not exactly what happened here.
And so are there any other red flags? Because I'm still unclear about the model, and maybe it helps to talk about what Bayesian Bayesian, my layperson's understanding of Bayesian reasoning is that you insert into your adjudication of a probabilistic claim prior understanding of the kind of probabilistic context of the claim itself, right? So if that makes any sense.
So maybe we can talk about, the claim that they made. So what they did in the paper was that they modeled what would it look like if the signature was this DMS or the dimethyl disulfide. So the sulfide or the disulfide, two different elements. And that's the two things that they compared against. They didn't do other models to say what happens if it was this other type of chemical compound that has an emission or an absorption that's quite similar, or what happens if we're trying to match it to, say, carbon dioxide or any other type of absorption.
So they
features.
get their spectra, and then they go, does this fit the thing that we're looking for? And they go, it does, but they don't also say, does it fit a whole bunch of other things that we're not looking for? That sounds like a cheat. That sounds like the drunk man who's looking for his keys under the lamppost because it's dark in the spot where he looked for them. Like, surely you have to compare it against everything in order to come to a conclusion about the likelihood of one.
It is cheeky. Yeah, and there's another paper that came out late last year or early this year where another team from, I believe it was the United States, did exactly this on the exact same planet using their own JWST data. And they have a beautiful plot that compares I think they had 8 different compounds that they were comparing the likelihood, and they did not confirm this DMS detection, or even, I don't even think that they had a high likelihood of the carbon dioxide either. So you can see that just from 2 different teams doing 2 different sets of analysis, they're not agreeing. And that is always a bit of that's probably red flag number 1 in science, is that unless there's a consensus, something's not quite right. Which means there's more science to be done.
Right. And so when you say that the model has whatever, a 27% chance of being wrong, what you're saying is that the assumption that the spectra that we see in the light that's passing from the star through the planet, the assumption that actually does represent the gases that we're talking about, it has the potential to be wrong. But if it's true that it does represent those gases, then we're back to our 99% likelihood of those gases having been caused by life.
Exactly. It's almost like that DNA and handling question. Yeah, okay. Like, which one do we think is correct first?
Got it. And where does this leave your optimism about this particular planet? And how does the likelihood of life on this planet compare to the likelihood of finding life on other planets that we might have as potential candidates?
So, look, I really do think that this planet, so K2-18b, is probably one of the most exciting, and it's probably one that, if there is life, this is one that we will confirm it on first because of the sheer amount of data we have on it. And now every scientist and their dog are going to be looking at it to try and get more data to contribute to this scientific debate. And so I think it's a really good place to start. The jury, as I said, is still out. Do we think it's the water world? Do we think it's the lava world? Is it a big gas giant, a bit like Neptune? We don't know. And there's still more that we can investigate on that. So I'm not counting it down and out yet. I think there's still a really good chance that maybe this could be it. But there's also other ways we can look for life. And I think one of the other really interesting ways that we try and look for life is with technosignatures, is actually looking for life that might be like us, that is leaking radio signatures. And that is something that would, for me personally, be just the nail in the coffin for intelligent life. Absolutely does exist out there.
Yes, that's obviously more exciting than it being like 100%. Goo, algae and goo.
Yeah.
It's like, there's life.
What would you take? Intelligence?
It's slime. Yeah. We found slime. We found living slime. There's a slime-covered planet. And just, you mentioned a lava planet. Would it be consistent with the existence of life that produces this sort of sulfur if it was a lava planet? Lava doesn't seem very conducive to... No. So you're saying
no,
that the sulfur
lava's not conducive.
No. Okay, got it. So technosignatures then, let's just move on to that before we get to the big questions of like the Fermi paradox and, why you still have faith that we're not alone.
I do have faith.
Yeah, before we get there, then what tools are we using and how are we scouring the skies to look for evidence of technologically advanced civilizations?
Yeah. So with Technosignature, there's this program called Breakthrough Listen, and they're using some of the biggest telescopes, including some here in Australia, so the SKA and the Parkes Radio Telescope, to literally eavesdrop in on planetary systems. So to look at stars where we know planets exist or stars where we think there's a likelihood a planet will exist, and just listen. Just listen for a couple of minutes here and there. And what we're trying to do is look for anomalies in that radio data. We're looking for things that have interesting modulations, because when we record and when we emit radio data out, it's very much decodable because it's the way that we do it. We either do frequency modulated or amplitude modulation, things that we understand very well in terms of radio. And that's what we're looking for. And so far, they've looked at thousands and thousands of stars and haven't found anything yet. But there's billions and billions and billions of stars in our galaxy, and it doesn't mean that they're not out there. It just means we haven't found them.
And how systematically are we looking at this? Like, are we literally just starting from one corner of the sky and going chugga, 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 chugga down like an MRI scan would and looking at every single bit? Or are we using human intelligence to go, well, let's look at this bit and not that bit, and then maybe we missed a bit here?
We're using our big human brains to list what we think is most likely. So stars that are nearby us first is probably the most important, because we're looking at stars that could have life on a similar scale to us. So one limitation with radio signatures is that it's just light and it travels at the speed of light. So say you've emitted a radio wave today, it would take 4.5 years until that radio wave reached our nearest solar neighbor, which is a very long time. So we want to look at stars that are nearby, so within hundreds to maximum 1,000-ish light years away. And even on that timescale, there's a possibility that maybe we find a signature from life that no longer exists on that planet. And certainly the other way around, they might be looking for us, and our radio signatures have only been traveling 100 and a bit years, and they might not think that we exist yet, just because our radio signatures haven't reached them. So
and
there's a lot of
strange,
limitations.
Crazy way, if we want to blow everybody's minds like we're 15-year-old stoners gazing at the sky, I've heard some physicists suggest that if they were looking at our radio waves that are originated from this planet 150 years ago, they would be right to say that there's no intelligent life, technologically advanced life on planet Earth, because there isn't yet there
a radio
because
wave.
Time and space are relative. And so in the timescape that they inhabit, it's true to say that it's 1850
We don't
here.
exist.
Yeah. Or whatever.
Yeah, exactly.
Which is kind of crazy.
Yeah.
It's not just that they're waiting for the light, it's that the traveling of the light is intrinsic to the existence of time in itself.
We're all frozen in our own little pockets of relativity, which it really does hurt my brain sometimes when I fall asleep just thinking about the scale of everything. I don't know if that's a me problem or an everybody problem, but the scale of
I think it's evidence of some
amazing.
sort of wisdom. I mean, it's better than going to sleep thinking about Pokemon.
Or lack of wisdom.
Yeah, I don't know. And so why are we assuming that that the best window, the best time window in which to catch an advanced civilization would be recently? Like, isn't there enough time for advanced civilizations to have risen and fallen 10,000 years ago in our time? And so it shouldn't really matter whether or not, isn't it a bit parochial to assume that they would arise at the same time we do?
Similar to us. Yeah, I guess it's not necessarily the best time. It's probably what we're deeming like a convenient time that we would exist within the similar time periods. Whereas we might be looking at stars that are, say, 10,000 light years away, and say we find a technosignature from that star. That is now a very different place than it once was when that signature was released. And we're a very different place than we once were.
And we also have no hope of
ago.
Communicating with that civilization, because by the time our message gets there,
all.
They will have moved on or died.
No, not unless you've read the 3-body problem, and then we're all in a problem.
A surprisingly good television adaptation as well. Did you ever see the Netflix show of the 3-body problem? Or the Apple
I
TV
did. I quite liked it.
Yeah, I thought it was good. Good one to check out if you're a sci-fi nerd. Okay, so, all right, so we're looking for all of this stuff. I'm also tempted to ask whether or not artificial intelligence, which a lot of people are really optimistic about in this space, is going to revolutionize the way that we're able to crunch all of this data and find inferences in, signals in the noise. How will that work?
Oh, it already is helping us, has been for the last decade or so. So, and this is actually near and dear to my heart because it's what I do. But with optical data, is I use artificial intelligence to sift through enormous amounts of optical data. And we do the same thing in radio data. So it helps us with dealing with the data volume. So the amount of data that's coming in and just, you can't have a human look at it. It's physically impossible. And so you can train AI algorithms to help flag things that are interesting. Of course, there's limitations, but it is game-changing, and we'd be amiss not to be using it.
When you say you've been doing that for a decade, it's only been 3 or 4 years that we've been able to get ChatGPT to write recipes in the style of a Shakespeare sonnet or something. So what do you mean by AI? Are you just talking about
old school,
about computing power or what? Because that strikes me as a bit different. Yeah. Running a computer program to find things is like a...
No.
Yeah.
We're talking about like classic machine learning, so like a convolutional neural network or using something like unsupervised clustering algorithms. So things that have in principle been around for decades. The mathematics of them, we got very good at it in the last decade or so, and ChatGPT has just exploded in the last 2 years. And that's a large language model that uses this idea of really complicated node connections, but the mathematics for how that works has been around for a long time.
Right.
So we've been using
so of course you
more
don't need
simple
a language
versions.
model to look at data.
No, exactly right. You can use much simpler models. Though we are exploring how we could use things like large language models and something called a vision large language model as well. So where you give it an image and get it to help. So that's actually a project I'm working on at the moment with a couple of students. Is can that help us in astronomy? And if so, how? And if not, can we make it, essentially?
And so what would that look like? You feed it an image, and what's the goal?
You feed it an image, and then you'd feed it a question. So I might feed it an image of, say, a picture of a galaxy that I took, and I might ask it a question, is there a supernova in this galaxy? And instead of me having to run algorithms to do the actual, how I would normally look for a supernovae, it has been trained on examples and examples of it, and it can say yes or no. And then I can go from there. Right. Or a lot of other things. Yeah.
Okay. So it could be almost like one of those kids' games where you have 2 cards and the picture looks almost exactly the same, but there's one slight difference that you have to pick. And the AI is just ingesting hundreds of thousands of images of different galaxies, and it's noticing things that a human wouldn't?
Yeah, which we get it to do anyway. We have AI systems that do that, but without that human interface, so that being able to actually talk to an interface like a human, which is what we do with things like ChatGPT and other models, where you can physically just say, I have a question, here it is. And I think that is a bit of a barrier between having to physically write your algorithms, which is what we do now, and then getting anybody who might not have written those algorithms to actually use them. I personally, I'm big on the AI train of when they're used ethically, they are so powerful and can really help us in a range of different ways.
If you were a betting person, do you think that AI is going to change the game in terms of finding life? Like if you had to, if you wanted to make a bet with me about the next 20 years, do you think it's going to happen?
I would make that bet. I'd bet you Dr. Pepper, my favorite beverage in all of the universe, that there will be AI somewhere within the discovery of life, whether it's a technosignature or a biosignature. There would be an AI algorithm used within that, probably for model matching, probably for looking for anomalies and things.
Right, but do you think that we'll get a positive hit in the next 20 years?
I really hope so. I want that Dr. Pepper, so I'm going to say yes.
Well, I'm glad that you like the taste of foul medicine, which is what Dr. Pepper tastes like to me. Foul, fizzy cough syrup. But we can hash that out.
I don't know what that says about my childhood, but I love Dr. Pepper.
But you grew up here in Australia, right?
I did.
And there's no real Dr. Pepper here, except for in boutique American stores. No,
exactly. So when I came back from the US just a month ago, I bought 25 kilos of it back.
Wait, are you serious?
Customs loved me. Yeah,
That's 25
I'm
litres
dead
of Dr. Pepper. That's
Yeah.
75 cans of Dr. Pepper.
Yeah, it was a suitcase and a half.
You brought
I had to
3
declare it.
cases of Dr. Pepper.
I did.
You are such a loser. It's unbelievable. I did not know this about you. Wow. For someone with your pedigree, that is embarrassing and shameful. And I can't believe you just admitted
I know. I should be ashamed. And that's okay. I will take that to the grave.
Okay.
But they're the two things that I'm passionate about in life is
Great.
Dr. Pepper and the fact that aliens exist.
Okay.
Maybe we'll find them.
All right. When the aliens come, I'm going to have them on my side about when the Dr. Pepper wars. You're going to be roundly humiliated when they tell you how foul it tastes. So the question of where your confidence in the existence of extraterrestrial life derives from is interesting because it is a bit depressing, I feel, that we've been hunting and it's not obvious that there's anything there. I mentioned the Fermi paradox, which is basically just the idea that if life is as spontaneous and readily emergent as it seems to be on planet Earth, then there should be heaps of life across the cosmos that is detectable, but it's incredibly fecund here and totally barren out there. So what gives? How do you explain that?
Yeah. I think my favorite way to explain the Fermi paradox is there's a theory called the great filter theory. And it's this idea, and this is the solution to the fact that we don't see life everywhere. So Enrico Fermi, who came up with this question over 60 years now, sat down with colleagues at a table and just went, well, why? Why do we not see aliens? But, we exist. Why shouldn't other people exist? And it was a bit of a funny joke. And then decades went by. We've been searching. We've been doing what we call SETI, Search for Extraterrestrial Intelligence, for decades and decades and decades. It's not a new thing. And it's exactly what you said. We see nothing so far, nothing out there. And so one solution to the fact that we're not seeing this universe teeming with life everywhere is that there's a great filter and that we happen to be on the good side of the great filter. Now, what the filter could be is any catastrophic event that could end life. So say you're an early Earth and you're forming and all of a sudden you were bombarded with asteroids that, change your surface chemistry or bombard it so much that the life can't evolve to a certain point or wipe out life to a certain degree. Or maybe it's an event where you are orbiting your star and your star has a massive solar flare that will wipe out early life. And you just can't evolve past this kind of hiccup point. And the idea is maybe we did. Maybe life is very basic life, teems everywhere and then dies very quickly. And we just didn't. And I think I'm in two minds of that. I think it's an excellent theory in principle to why we don't see technosignatures everywhere, why we just don't see intelligent life everywhere. But also it's an incredibly depressing one that the universe could be very, very hostile on the grand scheme of things. And we got very lucky, which is also quite humbling.
You're articulating a fairly sunny picture of what the great filter might be by placing it so far in the past at the dawn of life. Other people
I can talk about we might be before the great filter.
Well, that's right. Or if you want to stay mildly optimistic, you might say that the great filter emerges as intelligent life develops civilizations, but that generally speaking, the kind of tool-making intelligence that gives rise to civilizations also gives rise to tools that destroy intelligent civilizations. And so maybe
100%.
nuclear weapons and warfare and climate chaos and things like that are candidates for great filters that we may have gone past. Maybe we went past, maybe we, but then, yes, there's another school of thought that says, yes, maybe we have to wait and see what happens over the next 200 years to know whether or not we extinguish life on this planet, in which case that would also be consistent with the Fermi paradox, which is that actually there were heaps of intelligent civilizations, but they never last for more than the blink of an eye because they snuffed themselves out. So we're not hearing from them.
Yeah, you're exactly right. So I tend to be a positive optimist. I try to be sometimes, but that is very much like the glass half empty of very much so. We are, and I think it's very true right now. We're at a very critical point where humans have evolved technologically very, very, very quickly from our industrial age to now technological revolution. Like, fantastic for us. Look at everything that we've been able to do. Look at what it's done to our planet and to societies, really. And I think we're at a really interesting point where that idea of the great filter, we haven't reached it, could very much be true. Maybe intelligent civilizations just don't survive very well when they're too technologically advanced. And I think
that is a good explanation for why you wouldn't find technosignatures when you look at the sky.
Yes.
But the virtue of your more optimistic interpretation is that it's a better explanation for why we don't find biological markers, because no matter what we do to the planet, it's highly unlikely that we're going to annihilate all life on Earth, right? We might annihilate human civilization and send us back to the Stone Age. But there's still going to be cockroaches, and there's still going to be shrews and or shroots or whatever they're called, the little rodenty things running around, and they're going to be emitting whatever they emit that would be visible by alien civilizations, which is perhaps, even though that's depressing in itself, it does give credence to your claim that maybe we are special nonetheless for having gotten over some hump. I mean, maybe the great filter is the emergence of biological life in the first place. I mean, maybe it is really, really, really unlikely that inorganic compounds start replicating themselves and get us off to the races in the first place. How do you evaluate that probability?
Yeah, well, and I think there's a lot of research that goes on to how do you take inorganic compounds and spontaneously essentially get life? And does it have to be carbon-based life, which is what we are? We're this lovely carbon-based life. And we know that in the very beginning of the Earth, it was a very interesting place. It was a bit of a lava Earth. We had lots of different things that were happening. We did have some bombardments from asteroids. We also had some solar flares, lots of different things that were seemingly just right for basic life to start forming. But perhaps that isn't right on other planets. And this is another big question, is maybe we're looking for the wrong life. Maybe other types of life, so there's the idea of silicon-based life, could form elsewhere. They might look very different. Their metabolisms and how they metabolize chemicals be very different to us. And we don't have an example of that yet. So that's also another possibility, is maybe there's other life out there, which also could be very...
If you want to get all sci-fi, dystopian, futuristic and Silicon Valley about it, there's this other theory that maybe, we're at a tipping point at which consciousness and sentience are going to be absorbed into machines, and that there will be sort of, human-machine interfaces, and the singularity is near, and we're all going to upload ourselves into computers, and that we are a caterpillar that will turn into the chrysalis of the butterfly or the new AI or whatever. And so it's possible that it's conceivable that biological life gives way to some sort of technology that is no longer emitting biological markers but is still sentient. How do you evaluate that?
I'm quite
on the singularity train.
I love a good bit of sci-fi. I think, have you read I Am Bob, I Am Legion?
No.
Oh, I think you'd love it. It's fantastic. And it's this idea of you just spawned consciousness from our own brains into a bazillion different computer systems. And that's still life, in theory. So I think that's quite an interesting take. And I quite like the idea of, well, maybe life is teeming, but it's not life as we want to it biologically. Maybe it's this computer-generated life that still somehow is intelligent.
Would that still emit technological markers like radio waves?
It would, yes. So depending on the computer systems that they were using, you'd get markers based on how much compute power they needed to use, because computers and supercomputers are exceptionally power hungry. So unless they're using 100% renewable energy, they'd likely be using some type of, similar to us, that we're not on renewables yet, burning coal or whatever it might be to get their energy. And then you've also got heat signatures. So it'd be very hard to do, but in theory, if you had a planet covered in supercomputers, you could spot, if you had good enough resolution, where they were based on how hot the area was getting, because supercomputers you have to keep very, very cold. You basically are evacuating heat from the area and creating heat sinks outside of where they are. So that could be one way of spotting them, but your resolution would have to be very good. This would be a perfect Star Trek episode.
Exactly. That's right. And what about the idea that the universe is teeming with life, but they're intentionally hiding?
I love this idea. There's part of this is something called Universe Zoo, and the idea that life is out there everywhere and they are watching us right now and are like, ooh, these guys are too fragile to say hello to. We can't let them know that we exist. Maybe we are not stable enough. Maybe we are the zoo. And I think 2001 Space Odyssey, the very ending, if anyone hasn't seen that movie yet, you've had decades. You need to go watch it now. But the very ending of that, one interpretation is that he is essentially in a zoo. Aliens have collected him and are observing this person as an oddity. And
you're talking about not the very final shot where he's a baby, but when he shows up in the white hospital room.
The white room, exactly.
Have you read the book, Sarah?
No, I haven't.
You know that when they were working on the movie, Kubrick was like going off in all these harebrained directions. And who's the writer? Do you remember who wrote it?
No, I need to go read this now.
But whoever wrote the screenplay was collaborating with, I can't believe I'm blanking on his name, one of the great sci-fi writers of the 20th century, was collaborating with Kubrick on the script. And he was like, this is too messy. I think we need the Bible for what the story is before we make the movie. So he went off and wrote the book on the basis of the fact that they had wanted to do the movie. So it's like this collaboration thing where the book and the movie were conceived at the same time rather than one of them being based on the other. And the book is so much less pretentious and so much more clear in its explanation of what's going on than the movie is. Like the movie is very kind of Kubrick injecting his ambiguity into everything, but the book is quite clear about what is happening in that final passage. It's great.
What does the book say is happening in the final passage?
I don't want to spoil it.
Okay, I'm going to go read it.
Yeah.
I'm going to go read it.
Yeah, go and read it. And everybody should. It's great. It's a short book and it's totally gripping.
That's
the other explanation, I mean, again, I hate to be the person who's always like bringing the more negative and terrifying explanation in comparison to your sunny ones. But the more negative interpretation of the everybody is hiding thesis is that we're in a dark forest and there are marauding monsters in the forest. And anytime anyone creates a campfire, it gets raided by the marauding monsters and they all get killed. So everyone is hunkering down quietly.
Everyone's hiding. The
only people who survive are the people who make themselves small and invisible because there are civilizations that are bloodthirsty enough to extinguish anyone's that they see. So sleep
and
well
look, it's not
tonight, Sarah.
It's not a terrible idea. I think I have opinions on that because I think it is fascinating, the idea of what would it take for a civilization to be so advanced that they could actually leave their planet. And there's one train of like philosophical thought that you'd have to be peaceful. You would have to be a peaceful, worldwide, planet-wide peaceful civilization to actually get your shit together enough to off planet. And I quite like that idea because I just respectfully to the Earth right now, that wouldn't happen. We could not all work together to, say, move us off planet if we needed to do it right at this very moment. It's too geopolitically complex. Everything's extremely complex. We don't have stability even in things like we have food insecurity and we have poverty, and we're not as stable as a society, planetary society would need to be to really thrive off planet. And so this is my toxic positivity coming back in.
It is.
So I know I need to work on it.
I get, like, I admire the instinct, and at the same time, it just doesn't pass the bullshit test for me in the sense that, you know, Spain did not have to be a perfect place for Christopher Columbus to nonetheless leave and conquer the Americas and commit a genocide against indigenous people. You know, nor did Britain in terms of the settling of Australia.
Oh,
you know,
you're 100% right.
So it's
based on
entirely
our
possible that
observations,
you could be vicious and you could also go out and colonize other places.
You could also conquer. which I think if I was going to make a bet on another Dr. Pepper, it'd probably be that is more likely based on what we've seen from our own history. And in that sense, I would like to touch on this because I think you'll find this interesting, is that there's a huge debate of if we should intentionally put signatures out there. So we're leaking radio waves all the time, very low level leakage from TV stations, from radio stations, from all things communication that we do. And we're changing a lot of it to digital now, but we still leak a lot. We have, though, there's been, I think, 5 or 6 instances where we've directly used massive radio telescopes to send enormous signals, so signals with high power that can travel very far, directly to other planets. And there's a whole debate of, is that a good idea or not? And it's that dark forest situation, because you're lighting a fire. You're saying, we are here and we are smart. Hello. And you're hoping that anyone who picks up on them is kind and respects that. And it kind of goes back to the 3-body problem of, was that a good idea or not?
Yeah, it seems crazy to me. I mean, you would have to concede that there's at least a non-zero chance that they're hostile. I mean, if it was a 50-50 chance, you would say don't do it. I mean, don't. If there's a 50-50 chance that there's a murderer in the street across the road, you don't turn your lights on and off and on and off and wave flags out the window going, hello, I'm here, come and get me, Mr. Serial Killer. Right. And, how low does the probability of there being a serial killer in the house across the road have to get before you start doing that? I mean, you want to have some reason for being very confident before you start blasting broadcasts into the cosmos.
100%. And there's, I debated with a colleague once about this, who their opinion was like, oh, it doesn't matter. Anyone who finds us is so far away that it's going to take them hundreds of years to actually get to us, doesn't matter. Sure. But anyone who is very civilized and, potentially has figured out how to travel quite fast, use resources quite well, maybe that's not a problem for them. So I'm more of the fence of maybe we should be cautious, optimistically cautious. I want to look for technosignatures, and I really want us to discover and confirm that there is life out there. But I also, what is the possibility of other things? And I think that's an interesting one.
Yeah,
but
also,
again,
if the civilization we're talking about is, 7 light years away, and it's possible that these civilizations can travel at some significant percentage of the speed of light, then we're only talking about maybe a few hundred years to get here. And the same people who are telling you, don't worry about it, it's way far into the future, would not say the same about climate change. They would say, no, we have to care about what happens several hundred years hence to our great-great-great-great-grandchildren. It's not good enough to say, like, well, I'm going to be dead. Who cares what happens in 2350? Well, the people who are going to be alive in 2350 will care about whether or not they get invaded by aliens.
Yeah, exactly right. It's exactly right. And I think that's a whole kind of perception shift, I guess, of like, what are we doing right now that we won't maybe see the consequences of or see the rewards of. And I think that's a whole nother debate of trying to realize that, we need to think long term, just as humans in general. It's hard to do, but.
Yes. Should we settle other planets in our solar system, like Mars?
I think it would be a terrible idea to actually try and move people there. Like Elon's whole idea of, we're just going to move and we're going to go set up a civilization and we're going to live happily ever after. I don't think it's realistic. I absolutely think that exploring other planets on short-term bases is very interesting and very exciting. And the idea of sending astronauts for, say, 2 weeks at a time to get data that we otherwise could not get, fantastic. But actually living off-world has so many ethical problems. And one of the big ones is, and not a lot of people think about this, but if we were to, say, settle on Mars and we were to start reproducing, Martian, the atmosphere is very different. We'd have to have, this whole biosphere, but the gravity is very different again. And they've done models to show that people developing from infancy up would likely end up with really, really complex musculoskeletal problems and bowing of legs quite similar to what polio used to do, and have lifelong pretty much affections, like affectedness from from living on a planet that we haven't evolved to live on. And so I personally myself, this is probably my only rant, is that I think it's not responsible to go gun ho, like what we're seeing some people do.
Is that the only concern? Like, if you could resolve that concern by, I don't know, if there was either a medical intervention or the people, alternated their life between the surface of Mars and a, 1.5x gravity, spaceship that kind of equaled it out to about 100% gravity on average on 6 monthly stints or something like that, and they were free to come back to Earth if they wanted to, then does that change your thinking about it?
I don't think it changes it by much. I think the effort it would take to set up a full settlement might not be worth the reward. Because I guess the reason is why would we do it apart from, wouldn't it be cool to be a 2-planet civilization? But I think there's a lot of things and maybe on the hippy dippy, and that's okay. But I think there's a lot of things on Earth that we can use, resources and power and things like that to change first, if that makes sense.
Yeah.
I don't know. I'm not a fan of Elon's approach at all, I think.
I mean,
and that could be
take the man out of it, though, right? Like, let's assume that it's not Elon who's doing this. It strikes me that there are I understand there to be two main reasons for building a settlement on Mars. One is to hedge against existential risk, and just to say, like, for our long-term survival, be it a pandemic or an asteroid strike or who knows what, or a massive volcanic eruption that coats the planet in smog and makes agriculture impossible. There should be some people who aren't on this rock, who are on another rock, who could start over. And then the other one just seems to be a more kind of almost philosophical one, which is like, if humankind is going to flourish over the course of millennia rather than merely years, then at some point it's inevitable that we will become an interplanetary species, because that is what success as an intelligent civilization would look like. Therefore, we ought to retroactively do the things that we know we will have to have done in order to become successful, now. So that we make that, so that we kind of give birth to that new phase of human civilization, which seems as sort of weirdly kind of circular to me, almost like it's tautological, like we have to go to space because we have to go to space, because if we don't go to space, then we won't have gone to space. It's like, in the future we will need to have gone to space, and therefore we have to go to space. So we should go to space now. Hang on a second, aren't we pulling ourselves up by our bootstraps here? It's like we've just accepted as a given that we're going to end up in space, and therefore we have to do it now. Nonetheless, I feel the tug of that for sure, and I also feel the dismissiveness towards your critique about, like, there are problems to solve here at home, because there are always going to be problems to solve here at home, and you can always say that the same argument can be made for not going to the moon or for not investing in scientific research, because there are starving people in sub-Saharan Africa, and so we should invest all of our resources into mosquito nets to stop people from dying from malaria. Like, these are all true enough statements as far as the ethicist is concerned, but you also want to do cool shit.
I agree. I'm very on the team of cool stuff is incredible, and I think humans will eventually. My cool shit into cool stuff. It is cool shit.
Thank you.
Yeah. I've got a list, so sometimes I get nervous saying my S's.
Okay. I'll just psychologically swap every instance of the word stuff to shit mentally. You can say it.
No, I love it. Shit is great. But yeah, and I do agree that I think the humans do actually, if we are going to thrive over millennia, we will have to move from our planet, because there's going to be a point, and this is extremely, extremely far in the future, where Earth will no longer be habitable as our sun starts to die. That's not for 1 billion or so years, like an exceedingly long amount of time. But if humans, or if civilization is going to survive, we have to move planet. So I absolutely agree in the idea of, it is very cool and it would be excellent to see, and we're going to have to do it one day. I think my hesitancy is, and it's probably my own biases of thinking about if we had to do it right now. So I think in the future, and I think what's really, really cool is the idea of humans actually living underground on the moon and on Mars in lava tubes. And I think that's probably one of the areas that I think would be the most realistic. If we are actually going to go and set up a civilization elsewhere, it probably wouldn't be on the surface, you'd be underground. And that would also be a very different experience of life than what we're used to.
I want to see the stars. I don't want to be underground. If I'm underground, I might as well
You're
be. I might as well be in Arizona. I want to be. I want to feel like I'm on Mars. I don't want to be like. I don't want to sign up for the trip to Mars and then I wake up from the trip and I'm just in an underground lair. Could be anywhere. Yeah, screw that. Could be in Cuba Pedy, in an opal mine. What do you think? I don't know if you know the clip that has gone around a bit with Joe Rogan talking to the physicist about whether or not human life could have originated in the stars and how there might actually be species here who have been seeded here.
There was a group of scientists that were speculating that it's panspermia, the idea of panspermia, that it's possible that octopi had come from somewhere else. Some frozen eggs had actually come from somewhere else and landed on Earth. And these were like legitimate scientists who were contemplating it, not morons.
He says that octopus might be completely unrelated. And Brian Greene is like, I think it's Brian Greene. No, it's Brian Cox, I think. It's one of them. He's like, well, octopuses are actually really similar to they look weird, but they are biologically very similar in terms of their DNA. I don't think they come from another planet. But what do you make of that whole conversation? Is that in any way legit?
It's a legit theory. It's a theory for sure. It's this idea of it's called panspermia, and it's the idea of, maybe you have life, whether it's basic, microbes, maybe it's semi-advanced life that is spread out across the cosmos by a cataclysmic event. So you could imagine one theory that I do not think is correct, but is a fun one to listen to people really get passionate about, is the idea that life actually started on Mars, an asteroid hit Mars, and then whatever seeded that life hit Earth, and then that's what happened. And you can think of it that way. It's like almost this transfer of stuff, literally stardust, but in a more complex form, being spewed across the cosmos. And I think it's a really fun theory. I think we don't have any evidence that if it would actually happen in principle, because space is not kind at all to organic life, just radiation. We've got the vacuum of space. I think it's fascinating, but I think if it were to happen, it would be on life that's probably not like us, not like octopus. So maybe it's like tardigrades or something like that.
What's that?
They are the little water bears. If you ever Google water bear, they're the tiny little microbes that look like the cutest freaking things in the world. They have little tiny feet. They have like a little face. They are adorable. And
those are the aliens, you're saying?
Honestly, that's probably the closest thing we would get is them surviving elsewhere, because we've put them on the outside of the space station and they've survived. We've dehydrated the shit out of them. So you can take away like 99% of their moisture, completely dehydrate them, and then rehydrate them, and they reanimate. Essentially, they don't die, but they reanimate. They're basically in a coma and you bring them back. They are hardy little creatures. They can survive radiation. Like, they're fantastic, and they're tiny little creatures.
And the outside of the space station, it doesn't get more inhospitable than that in terms of solar radiation, absolute zero.
Solar radiation, temperature changes. Like, it's the awful environment. And a good chunk of them were able to survive to a certain degree.
What's the advantage of the, panspermia theory? Panspermia theory. What does it gain us? Because I don't understand why it's more likely that life would have evolved somewhere else in the galaxy and smashed into us, or on Mars and smashed into us.
Spontaneously.
If life is spontaneously coming into existence, isn't it just as likely to have done so here as somewhere else?
Yeah, I'm on that camp that I think it was more likely to just spontaneously, based on physics and biochemistry. I think it's just a theory that people love because it's interesting and it sounds very fun. And it's kind of interesting where it's the idea of maybe you could get things of very similar RNA or DNA to us. And I think what would be, if we're talking about alien life, the coolest thing that we could possibly concede, at least in my lifetime, I think, is actually finding microbes somewhere like Europa or somewhere like Titan, like a moon of Jupiter or Saturn. So in our solar system, but away from us, and trying to understand, are those microbes biologically very similar to us? Do we share similar DNA and RNA in those building block patterns? Or is it very, very different? And then I think then that panspermia conversation will come in more. But
because
right now,
if they are
theory.
related to us, then you would have to assume they have the same source, which is probably not on our planet if it's also elsewhere in the solar system.
Could be elsewhere in the solar system, which is
right.
very cool. Cool if true.
Who knows?
I wouldn't bet a Dr. Pepper on it.
Certainly not 3 cases of it that you're smuggling through Australian customs. I've just finished reading a book, Ross Douthat's book, about religious belief, in which he lays out the case for being a Christian, a Catholic specifically. And, he goes through a lot of the conventional arguments that anyone who's done the philosophy of religion or, who's dabbled in that knows. And I wonder what you sort of think of. I guess the fine-tuning argument is probably the biggest one, that it's too improbable that we exist in a cosmos where all of these necessary constants, the dials essentially of the universe, are set in such a way that it makes it possible for celestial bodies to gather in the way they do, for things not to collapse in on themselves, for stars to burn the way that they do, and then to produce the things that we are then made out of, and we assemble ourselves into thinking creatures. As far as he's concerned, that is just far too fantastical a story to think arose for no reason. And so his most plausible reason is that there is a creative consciousness behind the universe who brought it into being and set the dials just so. How do you grapple with that?
I think, full disclosure, I'm agnostic. I grew up going to a Catholic school, and I did really well at religion because I really like history, really good at it. But I myself, my personal beliefs is I'm very agnostic, where I don't think we have enough evidence either way for me personally to make a decision. And I personally don't believe in or don't worship any single god because I am that agnostic kind of person. And I think I've had conversations with lots of people about this specific fine-tuning point before. And I guess my rebuttal or my devil's advocate is that it looks fine-tuned to us because we exist in it, in the universe. But there's just as likely probability to, say, a deity or a god creating it than there being an infinite amount of universes, and this is just one of them that happens to have those particular physical parameters. And I think that's where I lean, is this idea of very much an Occam's razor type of girl. Even though I do love Murphy's Law, Occam's razor ultimately takes the cake for most things in my life, where the simplest explanation often is the most true. And at least in my mind, existence happened, therefore it did. And I don't need to reconcile myself with it. But I understand that others do. And I think that having beliefs, and I'm a huge proponent in the freedom of belief, because existing is really, really bloody complicated. Like, just being a conscious being is a lot. Nobody asked for this, and we're all here trying to exist on this planet. And I think trying to understand or reconcile with ourselves what that means looks very different to everybody. So I understand the positioning, I guess. But I myself
I understand. I think the agnostic position, I think you're articulating two different things. One is an agnostic position based on the axiomatic sort of fact of existence, which is just to say existence exists the way that it does, and we can invent a whole lot of stories about why that might be, or we can just accept the fact that we do live in this universe and we exist, and so let's try to muddle through. And to me, that's a perfectly legitimate move. But the other move that you're making, I'm not sure is as sound, which is to say that Occam's razor would drive us to believe that there's an infinite multitude of invisible universes, and that is a simpler explanation than that there's a creator who created this one.
Well,
those both seem to me to be wild propositions.
Both of them, I think, at least in my opinion, could be equally true because we have no evidence against one or the other, if that makes sense. And so based on the fact that we don't know why our universe exists in the first place, what was it that seeded that Big Bang? And the idea that that Big Bang could have happened in a multitude of different areas and different universes. Yeah, I quite like that theory. I guess it's probably not Occam's razor in that sense, but in other aspects of life, that's very much where I come from, of that kind of.
I mean, it strikes me as both convincing and also weirdly unsatisfying to say, well, of course we live. I mean, I sort of made this move earlier in the conversation, but of course we live in the universe or on the planet which is hospitable to us, because if we didn't, then we wouldn't be here to look at it.
Then we wouldn't exist.
Christopher Hitchens used to say that religious people marveling at how well the world is tailored for our life is a bit like the water in a puddle saying, look how perfectly this puddle has been tailored to the exact shape of me, the water. Like, you're shaped that way because the puddle is that way. Exactly. And if there was no puddle, you wouldn't be there to be remarking upon it. And yet it still feels like an unsatisfying dodge in some way. I can't quite figure out what's wrong with it, but a little bullshit detector in my head sort of goes off and says, like, wouldn't that just be a way to retrospectively rule out or just wave away any incredible event by saying, well, of course it had to go that way, because if it hadn't gone that way, then we wouldn't be talking about it?
Potentially. I think that's true for a lot of things. I find it really hard to reconcile if there is a creator, so that the universe was created, maybe it's a simulation, and that too would be a creation in a different sense. Say it is created. I have a hard time reconciling that we would know which creator it was, I guess. And that's probably where my agnostic sense comes in, where, out of the 100+ gods that you could believe in, I'm not convinced that any one of them.
Oh, yeah. I mean, that's
convincingly enough.
No, of course. That's the second move. Totally. That's the second move that the religious person makes. That is the completely illegitimate move, I think. Like, the world is miraculous and too miraculous to explain without some sort of intent behind it. Therefore, Mary was a virgin. I'm sorry, what? Wait, what?
Jump.
that doesn't follow at all.
Could I struggle with this? I guess also because you could also go down the route of just being completely be atheist about it all and say absolutely not. And I guess the scientist in me, I think when I was younger, I was probably more of that atheism of I just don't believe, therefore no. But as I get older, I think the scientist in me says, well, actually, I can't prove one way or the other. Hence, I have to sit on the fence, which I know people absolutely hate, and I'm so sorry. But I think that the weird scientist in me is that agnostic bound. And then you have all of the thought experiments that kind of pop up from it. But I have one of my best friends is Christian and also an astronomer. And I think the way that they reconcile it is actually quite beautiful, because I asked flat out once, I was like, how? Like, you're studying things that are billions and billions and billions of years old, but what you are believing in right now is not necessarily saying that. And they had a nice way of saying, well, maybe science isn't understanding what God has created, and God hasn't described what the universe is, or something like that. And it was an interesting reconciliation in the mind.
You're not selling it in a way that I'm buying it, Sarah. That's not impressive to me. No, I mean, I think it's perfectly legitimate as a scientist to rule out, to regard any commitment to a particular religious scripture and its, and its claims about history and cosmology as being invalid. And I think it's legitimate to be an atheist towards the religions of the book. But at the same time, I assume that when you say you're agnostic, you're talking about a deeper kind of question about whether or not there's a purpose behind the whole thing. That is unknowable. Yeah. What do you think the odds are? Last question. Yeah, sorry. Jump in.
No, I was gonna mention simulation, but I think you might be mentioning it.
Yep, go for it. What do you think the odds are that the whole thing is inside a gigantic technological AI?
think the odds are extremely low if their universe is like us. So for our universe, we would really struggle to actually simulate a universe like us based on how we can actually make computers. And it's all about the fine detail of actually making electrons go. Even if you were to use qubits and use quantum, the actual size of the computer and the amount of time it would take for either the speed of light or the speed of an electron to communicate across the mega supercomputer doesn't work to actually simulate how many parameters you'd need for a universe like us, because our universe has just an obscene number of elements in it. But
aren't you assuming that the top tier level of reality is comprised
it
of
can
the
be completely
same
different
stuff? Yeah. What if all of
so
this
that
is taking place inside the equivalent of an electron, in some other plane?
Yeah. So I think it's unlikely if they're like us. It could be likely if they're completely different physically. But even so, it still is a physical-based universe, as in we're bound by the laws of physics. That's just what simulations are. It's code that says physics will say yes or no to this. And that doesn't change what our life is. And somehow that's actually very comforting to me, and I don't mind it. I would not be upset if we were a simulation. I'd be upset if someone turned us off. That would be rude. But I wouldn't be upset if this happened to be a physical simulation in a different engine.
It would certainly explain why there are no other civilizations in this huge cosmos. They're just like, they're looking at us and they gave us a big backdrop.
Yeah. Well, just one giant thin. Well, to explain why I keep forgetting why I'm going to the fridge.
Occam's razor, Sarah. Occam's razor. You're just getting old and doddering. Sarah, it's lovely to see you again. It's great to talk to you. Thanks for unpacking all of this with us.
Thank you. Lots of fun.